Hello my dear class 9 students. Let's come to the exercise midpoint theorem chapter. In this chapter specifically you have to learn two theorems. Sir has already taught some theorems, but the theorems which are important for your exams are this and the converse of this theorem. So let us start. What is a midpoint theorem first? Consider a triangle ABC. In a triangle, if the midpoints, what is the midpoint of this side? AB, D is the midpoint of AB. And what is the midpoint of AC? E is the midpoint of AC. If the midpoints are joined by a line segment, then this line segment is said to be parallel to the base and is equal to half of the base. This we need to show by midpoint theorem. This theorem is known as midpoint theorem since we are considering the midpoints. So what was it? In this triangle ABC, if AD equal to DB and AE equal to EC, you have to show that DE equal to BC and DE equal to half of BC. So let us start. Let us do the construction. Extend the line segment DE, this is the line segment DE, and produce it to F such that EF is equal to DE. These two are equal, that is E is the midpoint of DF. In that way we have made this construction. Now in triangle ADE and triangle CFE, you can see that this is F, CE. So these two triangles we are considering ADE and CFE. See, EC equals to AE. Where is EC? EC equal to AE. They are already equal. It is given from here. Next, number 2, angle CEF equals to angle AED. CEF equals to angle AED. This is true by vertically opposite angles are equal. And EF equals to ED. This is by construction because we have constructed this triangle in that manner. So, you have learned congruency. Triangle CFE is congruent to triangle ADE by side angle side axiom. Therefore, angle CFE is equals to ADE. CFE is equals to ADE. This is by corresponding part of congruent triangle CPCT. Angle FCE is equals to DAE. This is also by CPCT. That means all are equal. Whatever other angles that we are having, CFE, ADE, these two, then this and this were already equal. Then CF is equals to AD, that is this and this are equal. These two are equal. Now the angles, angle CFE, that is this one, and angle ADE, ADE means this one, are alternate interior angles. As you can see, alternate interior angles. And similarly, I can say the same thing for FCE and DAE. They are also alternate interior angles, which means CF is parallel to AB and CF is parallel to BD. Isn't it so, children? And CF is also equal to BD. Since BD is equals to AD, it is proved that CF is equals to BD because AD is equals to BD. Thus, it is showing that BDFC is a parallelogram. In a parallelogram, what are the properties? Opposite sides are parallel and equal. By the use of the properties of parallelogram, now we can say that BC is parallel to DF and BC equal to DF. See, since is a parallelogram, so opposite sides are parallel. So BC is parallel to DF and BC equal to DF. and also therefore BC is parallel to DE, and since DE is half of DF, so DE is equals to half of BC. This theorem you will have to remember very nicely. This is the proof for midpoint theorem. Next we will move on to the converse of the midpoint theorem proof. Now let us come to the converse of midpoint theorem. This theorem states the opposite of the midpoint theorem that you have learned. The line drawn from the midpoint of one side, this is the statement of the theorem. This is a triangle. The line drawn from the midpoint of one side of a triangle and parallel to another side intersects the third side at its midpoint. So we have to show that in a triangle ABC, if a line is drawn from the midpoint of a triangle, one side of the triangle, such that the line segment is parallel to the other side, then this line will merge to the other line segment at its midpoint. Now, it is given that a triangle ABC in which D is the midpoint of AB. D is midpoint, that is given to us. Next, DE is parallel to BC, that is also given to us. We have to show that E is the midpoint of AC. Now, construction, we are taking that E is not the midpoint of AC. Alright, since we have to prove that, we will for the time being take E is not the midpoint of AC and let F be the midpoint of AC. F is any other line point on this line on this side AC. So F is the midpoint of AC that we are considering. Proof: since D is the midpoint of AB and F is the midpoint of AC, so by midpoint theorem we have, in a triangle, if the midpoints are joined by a line segment, then by midpoint theorem we say that this line segment is parallel to the third side. So DF must be parallel to BC. But it is given that DE is parallel to BC. Now how come it be true that from one point only two different divergent lines are going and both are being parallel to a given line? If DF is parallel to BC, that means that DF should also be parallel to DE, but this is not happening. This means that our assumption, what we assume that let F be the midpoint of AC, that assumption is false. So we have arrived at a contradiction. So that is our assumption, that F was the midpoint of AC is false. So F cannot be midpoint of AC, E should be the midpoint of AC. Therefore, E is the midpoint of AC, hence it is proved. So this goes our converse of midpoint theorem.